Today, we start tackling 9.3, and we are going to be looking at the start here for, the domain of each rational function. Now again, domain is your x values. So what I'm actually asking you is, are there any denominator restrictions? In other words, are there any values that could cause my fraction to go to a divisor of 0, which is undefined, because we don't want to do that. That's what we want to avoid. So basically, I'm going to ignore the numerator for right now and put all of my focus into the denominator, whether that's factoring it, making an equation out of it, whatever it happens to be. So like for instance on number 1, I see a difference of squares. So I'm going to go ahead and I'm going to factor that whenever I'm given the opportunity. And then whatever those x values are that I get out, and some of you may have even turned that into an equation and then just taken a square root, which is a legitimate strategy here. Those are going to be the two values that won't work. But if I'm being asked for the domain, I could do it one of two ways. I could do something really big with the negative infinity to this and this, or we can simplify it. So something new here possibly. The R with my double baseline stands for all real numbers. Now it's not all real numbers because I have a couple that don't work. All real numbers not equal to -4 or 4 would be my domain, because I want every single real number except the ones that make my denominator equal 0. So whatever I get for those values, if any, I can just put the not equals with that and kind of make my notation a little bit easier to deal with. And as you're moving from problem to problem on these, the way you factor may be a little different. Okay, again, these aren't squares and a sum. I couldn't have a sum of squares anyway. But I can do something like take an x out of there. Sometimes it may just be that common factor. So then, not only could I set the x plus 7 equal to 0 and find out that I get a value of -7, I also can set the plain x value equal to 0. So 0 and -7 would be my two values that would cause a problem. Because if I plug in 0, of course, I'm going to get 0 out. That's bad. And if I plug in -7, I'd get 49 plus -49. So I want all reals not equal to those two that cause my denominator a problem. It's all about the denominator. So on any of these, again, any factoring I can do, I will. And whatever x values are going to be the values that cause me an issue on these. Now, to make a connection with what we're going to be doing today, because you're like, okay, I see, we're just setting the denominator equal to 0. What's this do? These restricted values are going to be our vertical asymptotes when we start doing the graphing. It's going to be where our graph comes up really close, but then never crosses. So we're kind of getting a little bit of a preview to that as we work on setting our denominators to basically not equal 0. Because those zeros or those errors are going to be the exact values that are helping us to create our graphs. So what's that lead us to? Well, we've done things with parabolas. We've done things with absolute value functions. We've done a little bit with linear stuff. Now we're going to get up into another type of graph called a hyperbola. Now, hyperbolas typically break into pieces, as you can kind of see from these pictures down here. The parts of a hyperbola typically are broken into what are called branches. Instead of calling them pieces, we have a little bit more of a technical name for them. And for my parent graph, which is just y equals 1 over x, which we will pull up here so we can take a peek at what this looks like. Kind of looks kind of funky. Now, like we mentioned when we were graphing before, just because I can't see this line continue to come down doesn't mean that it doesn't. This is going to infinitely go down, infinitely go left, infinitely go up, infinitely go right, which is why it mentions the domain and range for these would be all non-zero numbers. The only value that I can't plug in here that works is 0, because of course 0 would make this undefined. And I can't divide 1 by some number and get 0. So when we say the domain and range are those, my asymptotes would be at y equals 0, otherwise known as the x-axis, and x equals 0, otherwise known as the y-axis. And it'd never cross either of those axes at all. So, since we have that up here for our first one, and we have the picture up already, well, we already talked about what the asymptotes are going to be. And I can actually figure that out just by looking at the picture. I notice my graph comes really close to the x-axis, but it doesn't look like it's going to go through it. And it comes really close to the y-axis, but it never really goes through it. And I always encourage people to draw their asymptotes because, well, it reminds you not to go through that particular point. So, we know our asymptotes are at x equals 0 and y equals 0. And once we get that situated, we basically know what our domain and range is going to be. My domain is going to be every real number except that asymptote value that I never cross, because we're going to come right up next to 0 here, go off to positive infinity, close to 0, off to negative infinity. And my range, my y values, are going to do the same thing. Down to negative, up to positive. But we never get that one value at 0. So once I know my asymptotes, I basically know what my domain and range are going to be. It's going to be everything except that particular value. So when I go to graph, I do want to be accurate. I don't want to just put some scribble in here. And you'll notice with your vertical asymptote, I get the error message. So if I tried to plug in 0, it wouldn't work. So for the rest of my values, and I know we've already got them here, but I can see, 1, 1, 2, I'm at a half, and I can at least get a couple of points on each side of the asymptote, so I can make a somewhat decent branch drawing in there. Do I think you need to write every single one of these points? No, not really. Even if when you had these, you just used mainly the whole numbers that you get, or maybe even like the decimal values like you've got here, I'm fine with that. To me, that's going to be accurate enough. As long as you remember, again, just because it looks like the graph stops here or stops here, it doesn't. It keeps going off to infinity. Otherwise, I'm good with this. So let's see here. Let's see what happens, though, when we move away from the parent graph, when we start shifting things around a little bit. Let's see if we can figure this out. Now, what seemed to have happened here? Looks like my vertical asymptote may have moved. Let's look at the chart. Yes, it did, because now I'm getting the error message at x equals 1. So let's see here. My vertical asymptote is at x equals 1. I wonder if this is a coincidence. Probably not. When we're doing these, my shifts are going to start showing up in different places. Any plus or minus that you see in the denominator is going to shift your vertical asymptote. Because basically all I'm doing here is taking that denominator, setting it equal to 0, and figuring out what the x value is going to be. Add 1 to each side, there's my vertical asymptote. Now at x equals 1. Notice my y value, my horizontal asymptote, didn't move at all. Because I see it approaches 0, it approaches 0. So I haven't seen yet what's going to affect that y. So we'll get this one drawn in. My horizontal asymptote is still at 0. So I'm like, okay, well, what does that mean? It means basically I know my domain and range already. My range goes with wherever my asymptote is my horizontal. So these always go together. And then my domain always goes hand in hand with my vertical asymptote. Every time. No exceptions at all. That those four things are going to have a combination. But you will maybe notice a little bit that by changing the numerator, it's not quite as close to the asymptotes. It's kind of stretching away a little bit. And we'll talk about that on this next one when we get a little bit deeper into it. But as long as you can remember that vertical asymptotes and domain go together, horizontal and range go together, good deal. So finally then, so what we're going to do is we're going to type this in and we're going to see what some of these effects are going to continue to be. Here's one thing I will warn you of, though. Always, 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 whenever you see plus or minus anywhere, always a good idea to use parentheses. Because if you don't, strange things can happen. So, let's see here. Ooh, we got all kinds of movement this time. Looks like our vertical asymptote shifted left 3. Not a coincidence. And that my horizontal asymptote now is below the x-axis, maybe at -1, might I say? So I start to see a little bit. I'm like, okay, I can kind of see what's going on here. Basically, I figured out my asymptotes are x equals -3, because I can always just set my denominator equal to 0 or look at it like it's a shift. But then my horizontal asymptote is going to be determined by the up or down shift, the number on the end, just like it has been for parabolas and square root functions and logarithms and everything else. But the question might come back here too, and let's look at the chart for this. What exactly is that a value doing? So let's get some points plotted here. We'll get our asymptotes in. And basically what I'm going to realize here is, okay, let me get some points. -4, -3, -5, -2. And I'll be honest, even just getting 2 points on each side of my vertical asymptote is going to give me enough information to be able to make this work. Because when I go back and look at my graph, I'm like, okay, it's going to hug the asymptotes. So by drawing them in, I have those borders that let me know where my graph is going to be drawn. But here's a couple of things that we may not have thought about before that we may be able to see now. So I'm going to pull this down a little because I want to be able to see number 2. Okay. What does A do to the graph? If A is greater than 0, and it may have been a while since you've had to deal with quadrants here. Remember, when we're talking about quadrants, we start in the upper right and we go counterclock here. Well, why am I labeling the quadrants? Are we like plotting points or something? No, but you can figure out where the branches are going to be based on the A value. If A is greater than 0, so like it was in number 1, or like it was here in number 3, quadrant 1 and quadrant 3 are going to be where your branches are at. It'll always be at least taking a majority of them in those places, because some of you may get detailed on me and say, well, part of that's in quadrant 2. I know, but a majority of it would be in these two. If it's less than 0, like it was in example 2, quadrant 2 and quadrant 4 typically will be where your branches end up. And again, that's just kind of a guide on where things should end up. So if you type something in and it doesn't work, maybe you forgot the parentheses or something like that. And then the literal value of A changes the width of your branches. The smaller the value, the tighter they are to the asymptote. The bigger the value, the further they tend to stretch away. That's not as big of a deal as understanding the branch part of things in case something goes screwy sometime. And then we talked about the h and the k values. The h value is going to be like my left or right shift, just like it's been when it's inside of your square root or inside the parentheses with a logarithm or anything like that. And again, just like before, they're the opposite of what I would think. Plus is going to be a left shift. Minus is going to be a right shift. And my k value on the end is still going to be my up or down. But those do stick with the values that I had. I don't have to switch signs on those or do anything fancy. So my down 1 got me my horizontal, my left 3 got me my vertical. Okay? So lots of things that should look like repeats of things we've done before, because basically they are. It's just a little bit different of a format with drawing a hyperbola instead. So we are not going to do all of these, but I want to do a couple of them just so we can get a little bit of practice playing with these. So identify the parts, then graph, because we can figure all this other stuff out before we ever even do a graph. For instance, where's my vertical asymptote going to be? -1. Because again, I can either set this equal to 0, or I can say, oh yeah, +1 means it's a left shift. If I move left, it's going to be negative. Horizontal asymptote, y = 2. And once I know the asymptotes, I know the domain, which goes hand in hand with my vertical. All reals not equal to that asymptote, because that's where I get my undefined value. And the range and the horizontal asymptote go together. Range is everything but 2, where my horizontal's at. And basically everything else that I'm doing with these, I'm going to draw my asymptotes in, because I don't want to break any rules here and start going over them when I shouldn't be. And even if I didn't have a graphing calculator available, I could still make a pretty good sketch of this by saying, okay, I can't plug in -1. Maybe if I were going to go draw a sketch of this, I would use 2 values to the left, and then I would use 2 values to the right, just to kind of see how close to the asymptotes the curve's going to be. Now, if you have a graphing calculator, for Pete's sake, use it. But otherwise, I could just plug those values into the expression and get the values out. Does it take longer than the calculator does? Well, yeah, but it's not the worst thing ever. And remember the parentheses. Let me get those in. So let's see what we got working here. Looks right. My horizontal coming right along here. There's my vertical. I can see it going up and down there. And then I'm just going to take those values that I had jotted down before. And a lot of times what will happen is those will end up being your whole number values. So -2, -2, -3, 0. And then at 0 and 1. And I find out that's kind of far away from my asymptote. Well, why is that? Because again, the larger this a value is, the further it's going to be from nearing my asymptotes, at least here towards the middle. That's all we're doing here, basically. So I'm not so worried as much about the graphing as I'm just understanding the other stuff. So let's take a minute here. Let me get the calculator out of the way. Let's just talk some domain, range, vertical, horizontal asymptote. Make sure that's going okay. So let's see here, number 5. Vertical asymptote for 5. X equals 1. Which means my domain is all reals not equal to 1. Horizontal asymptote. They're stunned. Y equals -3. Which means my all reals except -3. Now, am I necessarily going to have some sort of a shift on every one of these every time? No. You're like, dang, he's not going to graph this one. Not yet, because I want to make sure if we have these basics down, the graph part's going to just help us to kind of make sure we're doing it right. Okay, 6, I get to do the easy one. Vertical asymptotes at x equals 3, because I'm moving right 3. Which means my domain is all reals not equal to 3. Okay, I got that part. What's my horizontal asymptote this time? Y equals 0, because there is no plus or minus here at the end. If there's not, it just stays where it would, like for my parent graph. So my range would be all reals not equal to 0, and when I do my graphing, I should see that. That way, if I do something silly on the calculator, it's not like I'm going to get stuck. And actually, this one I want to see visually here quick. This will be our other one that we graph. And there's just one other one I want to take a peek at, and I'll let you get a little flex time to get going here. So, all right, -1 divided by, and don't forget my parentheses. And I notice, okay, there's my vertical at 3, and we're hugging the x-axis, so we're at y equals 0. Okay, I got this. Let me get these in here. Just so I don't do anything crazy. All right. So, and it's my vertical asymptote. Yeah, find that error, and I want to work with values that are right around it. So like 2, 1, 1.5, 4, -1, -0.5. and I'm set. And this time, since my A value was 1, notice it was a lot tighter to the asymptotes than number 4 was. Last one, and I just want to do the basics on the last one here. Running down to 8. Maybe. Come on. All right, too far. Vertical asymptote on number 8. Zero, because I don't see any plus or minus down here. We're just working with a parent graph. So all reals not equal to 0. I'm with you. So then where's my horizontal going to be? 1, y equals 1. All reals not equal to 1. And again, just for sake of making sure, divided by x plus 1. And again, this gives me my opportunity to notice we're hugging the y-axis, so I know my vertical asymptote would be at 0. And we're just above here with my horizontal, which means we're coming near to 1. So I feel good that I have this typed in right. And I noticed that 1 up here, so we're going to be tight again. So there's my error message, so I'm going to hang close. And again, just a couple of values that are really close are all we're going to need. Make sure that you get your branches heading towards negative and positive infinity for both your domain and your range. So your task is to take on the bookwork from the other sheet that you picked up. This will end up being our second assignment because we had that one sheet with adding and subtracting with the rational denominators before, so this will be number 2. We will